So we are live again, and now we'll be starting with API calls. And start.
in React is interact with an API that lives outside of your application. Usually what you're doing is either requesting information from an API or sometimes submitting information to an API. Whenever you're requesting information from an API in React, usually you want to display or use that information somehow. So getting data from an API in React consists of essentially two parts. First of all, you need to get the data. And that would be using something like fetch or another tool for getting data like Axios. The second step would be to then take that data and save it to state. Once it's saved in state, your application can interact with it, it can display it on the screen, and all of the other benefits that come with saving something in state. So let's see some preliminary syntax as to what that might look like. And then as a spoiler alert, I'm going to show you why this is broken to do it this way. To start us off, let's do a fetch request to the Star Wars API. This is just a very simple API that will get us some information about Star Wars characters and planets and movies and stuff like that. I'll go ahead and resolve the promise that I get back from fetch. It will receive a response, which will be JSON. I want to turn that into a JavaScript object that I can use. And then with that data, we'll just console log the data for now. Okay, awesome. We have this object here. I'm not going to bother digging into this object. I'm just going to stringify the entire thing. So let me put that into state. And you know what? I'm actually using data in a couple places. Let's maybe call this Star Wars data and set Star Wars data into state. Okay, awesome. We have this object here. I'm not going to bother digging into this object. I'm just going to stringify the entire thing. So let me put that into state. And you know what? I'm actually using data in a couple places. Let's maybe call this Star Wars data and set Star Wars data. And then instead of console logging, we will set Star Wars data with the data that we get back. Then I need to make sure to update them here as well. Let's hit refresh and see what we get. Okay, there's the data from my API. Awesome. Everything seems to be working swimmingly. However, let me illuminate some.
So stringify does not change the structure and doesn't even make it a string. It's just a function to display the object, and not display like undefined or something like that. An object, right? In that way, it will be displaying what it returns, maybe.
Thing that's going on behind the scenes right now. I'm going to console log component rendered. Every time the app component renders or re-renders by React, it will run this console log. So let me open my console, hit refresh, and look at this. We've got an infinite loop of component rendering. Let me comment this out and hit refresh. Now, I want you to pause and think for a second, why was this console log running over and over and over again? Pause now and see if you can come up with an explanation for why it was doing that.
It was running again and again. Why? Okay, that's a good question. Hmm. I don't know. Maybe. I don't know.
The reason
Okay, maybe when we are calling the API, we are actually changing the state, and then since the state is changing, it is getting re-rendered. And
we were stuck in an infinite loop is because this fetch lives on sort of the top level of our component. Because of that, anytime the component the reason we were stuck in an infinite loop is because this fetch lives on sort of the top level of our component.
oh, top level. Okay, what does that mean?
Because of that, anytime the component renders, it's going to call fetch. And every time it calls fetch, it's going to set the Star Wars data, which is updating our state, and therefore causing React to re-render this component. And then it's running fetch again, setting the state, re-rendering the component, calling fetch again, setting the state, re-rendering the component. I think you get the idea. In fact, even though we're not seeing that happening with this console log commented out, it's still being re-rendered in the background. So I'm going to comment this out so that it actually stops re-rendering. And in fact, the only thing we really need to comment out is where it says set Star Wars data. When we had a console log here, I'll uncomment this component rendered and open my console. We'll see that we're no longer in an infinite loop, and that's because we're not setting state, causing the component to re-render. So this acts as a perfect springboard into the next topic that we're going to learn about, and that is how to handle side effects in React. So that is what we will tackle next.
Okay.
We're now embarking on a journey that leads to oftentimes considered one of the most confusing parts about React, and that is how to manage side effects. To really understand what I mean by side effects, let's take a look for a second at what React's primary tasks are. First of all, React is in charge of working with the DOM and the browser to render some kind of user interface to the page. The React team has created a really simple interface to allow us as developers to accomplish this with JSX and elements that look just like HTML. Under the hood, of course, React is taking that JSX and turning it into elements that can be displayed on the page. Another task, which we have mostly been learning about in this section, is to manage state for us. And if you think carefully about it, it's managing that state between the render cycles. In other words, React can remember state values from one render to the next. So that's another thing that React does, and we are developers to accomplish this with JSX and elements that look just like HTML. Under the hood, of course, React is taking that JSX and turning it into elements that can be displayed on the page. Another task, which we have mostly been learning about in this section, is to manage state for us. And if you think carefully about it, it's managing that state between the render cycles. In other words, React can remember state values from one render to the next. So that's another thing that React does, and we are allowed to hook into that state using the useState hook. And then naturally, its next task is sort of a combination of these two. It needs to keep the user interface updated whenever state changes. There certainly are other tasks that React is accomplishing, but you can probably boil the main three tasks down to these three. So then what is React not able to handle on its own? The major one that we're going to be discussing is any kind of side effects, or I put outside effects here. All that really means is anything that lives outside of React's purview or reach. So some examples of this are local storage on your own browser, for example. We can of course use code to access local storage, but React has no real hand in interfacing with local storage. Along that line, any kind of API or database interactions that occur in our code, we can write that code to interact with APIs, but React is not in charge of that code. Or rather, React has no way to know which APIs we're going to be reaching out to. Similarly, any kind of subscriptions you might might have. If you include WebSockets in your application, for example, you have a chat application that updates live. And as it turns out, even if you have two different pieces of internal state that you need to sync together or have one of those pieces of state react to a change in another piece of state, React can manage the state of each one behind the scenes, but it's not really looking at any kind of crossover between those two states. So in the end, it boils down to basically anything that React is not in charge of can be considered a side effect or an outside effect. So using this API interaction, for an example, if we look at our code from before, I commented it out so that it wouldn't keep infinitely rendering. We can see that React is essentially just doing what it's told. It's trying to put something on the screen, it's trying to manage state, and it's trying to keep state and the screen in sync. If state ever changes, it needs to re-render the component. As a side note, if this were receiving props and somehow those props were also to change, for example, if those props were a piece of state in a higher up component that then changed, this component would also re-render. So with our code living here on the top level of our component, React really doesn't have a way to stop us from setting the state here, causing the re-render, which would then set the state again, causing the re-render, and so forth in that infinite loop. So the React team gives us a really nice hook called useEffect. In the documentation, this is called the effect hook. And I like to think of it as a tool that React has given us developers to use sort of like a blank canvas that allows us to interact outside of the React ecosystem, which again mostly just consists of state, props, and user interface that it puts on the page. That allows us to interact outside of the React ecosystem, which again mostly just consists of state, props, and user interface that it puts on the page. And I like to think of useEffect as being a tool that allows us to synchronize React state with those outside systems like our local storage or an API. Now, before we jump in, I've included here a link to the documentation. If you click this slide, you will be sent to this page where you can learn about using the effect hook. Again, think of it kind of like reading the textbook before coming to class. Now, you don't have to scour every single word in the documentation, but I do want you to take a look at it, read through it, and then when you've got a cursory understanding of the effect hook, then we'll jump into the next screencast. As you're reading through this documentation, you'll run into a line that says, if you're familiar with React class lifecycle methods, you can think of the useEffect hook as component did mount, component did update, and component will unmount combined. So if you are familiar with class lifecycle methods, I actually want to implore you not to consider this tip. If you have no idea what I'm talking about, then that's totally fine. You can forget everything that I just said about class lifecycle methods. But if you are familiar with class lifecycle methods, the modern advice these days is not to try and think of the useEffect hook as a combination of these lifecycle methods, but rather to work on retraining your approach to understanding side effects in React. I know that might be strange for me to be contradicting the documentation, but I know that I'm backed up because this is an article by Dan Abramov, who is one of the core contributors to React. And he writes this giant blog post about understanding useEffect and essentially goes in depth into how we should not be thinking of useEffect as a way to hook into lifecycle methods, but rather as a way to deal with side effects in React. If you really want to deep dive, you can click this slide to go to this page. But if you're learning React for the first time, you do not need to go this in depth into useEffect at this time. So once you've had a chance to skim through the React documentation on the effect hook, let's jump in and start learning how to manage side effects in React. Let's begin refactoring our code here to use the useEffect hook. Just as we can access the useState hook on top of the React object, we can do the same with useEffect. So I can create a side effect by using react.useEffect. And useEffect has one required parameter and an optional second parameter. In this screencast, we're just going to learn about that first required parameter, and in the next one, we'll talk about the optional second parameter. The required first parameter for react.useEffect is a function, a callback function. And maybe so that's perfectly clear, I'm going to write this out as a function declaration. Although in practice, you'll almost always see this as an arrow function, and that's what we'll eventually transition to as well. And this function acts as a place for us to be able to put our side effects code. In the little example we have here, this fetch request is considered a side effect, and that's because it's reaching outside of React's ecosystem, but also trying to set some state in the process. Remember, this was infinitely looping because on the top level of our component, it was running this fetch and setting the Star Wars data, which was modifying state, and therefore re-rendering the app, which then just ran all the code again in this infinite loop. So let's move this fetch request inside of our useEffect. And that's it. Inside of the callback function that we provide to useEffect, we're allowed to put our code that has other side effects that interact with systems outside of React. And maybe more specifically, interact with those outside systems to keep them in sync with our local state in this component. Now, I do have a confession to make. We're actually only halfway there. If I uncomment my console log and hit save, you'll see that we're still having the same problem we were having before, where we're stuck in an infinite loop. Let me comment this line out so that it doesn't keep setting state. So what exactly is going on? I thought useEffect was going to fix this problem. Well, it turns out that the code we put inside of this callback function, if we don't provide a second parameter to our react.useEffect function, then there's almost no difference between putting our code inside of useEffect and putting it outside of useEffect on the top level of our component. There is one small difference, and that is anything that we put inside of this callback function is guaranteed to run only after the user interface has been painted to the screen. In other words, only after React has taken interface has been painted to the screen. In other words, only between putting our code inside of useEffect and putting it outside of useEffect on the top level of our component. There is one function, then problem. Well, it turns out that the code we put inside of this callback function, if we don't provide a second parameter to our react.useEffect function, then there's almost no difference between putting our code inside of useEffect and putting it outside of useEffect on the top level of our component. There is one small
Now I know.
difference, and that is anything that we put inside of this callback function is guaranteed to run only after the user interface has been painted to the screen. In other words, only after React has taken our user interface, our elements, and created real elements on our page. So this callback function is guaranteed to run in a specific order only after this has been placed on the DOM, but for our purposes here, there's basically no difference. We're still stuck in an infinite loop. So in the next screencast, we're going to start diving into useEffect and understanding first why we need to provide the second parameter, and then what that second parameter is and how it solves this problem.
Dependency array.
I've made a couple modifications to our app here to try and demonstrate exactly what's happening within useEffect. I came up with the simplest little counter app that just has a single button that says add and something that displays what the current count is in state. The reason I did this was just to make it so that we had a really easy way to trigger re-renders and state changes on our app here. I also replaced our useEffect callback function with just a console log that lets us know that this effect function ran. You can already see what's happening down in the console, but if I refresh the site, we'll first get the component rendered console log, and then we get the effect ran console log. As we talked about before, the function we pass to useEffect will run after every render of our component. It essentially makes it no different than moving our console log outside onto the top level of our function, just like we have here. which means if we ever wanted to change the state within our use effect, we get caught in that loop like we've talked about a few times already. Now with my little counter, I can trigger a manual re-render by just clicking the add button. And we can see that when I click the add button, it updates the state behind the scenes, so it changes from 0 to 1, and it re-renders our component now with count equaling the number 1. We get our console log, which rendered because it's a function call here on the top level of our component. It then would have skipped down here and rendered our UI so that it could display the correct count now that count is set to 1. And last of all, it ran our effect. It then would have skipped down here and rendered our UI so that it could we get our console log, which rendered because it's a function call here on the top level of our component. It then would have skipped down here and rendered our UI so that it could display the correct count now that count is set to 1. And last of all, it ran our effect, which of course runs after every render. As we talked about, the first parameter to use effect is this function, but there's a second parameter, which, although I mentioned is optional, is something that you will almost always include, and that is something called a dependencies array. Now, don't let the name confuse you. The concept is actually not too terribly difficult. The array that we pass as a second parameter to use effect will contain values that, if they change from one render to the next, will cause this effect to run. In other words, it limits the number of times that this effect will run, or rather it determines when this effect will run instead of running after every single render. Now, if I leave this as an empty array, it effectively tells React, I want to run this function on the very first render of my component, but then there are no dependencies to watch and trigger this effect to run again. So it ends up being, it runs once when the component first loads, and that's it, never again. We can see this in action by refreshing our app, seeing that we did get effect ran, and then adding to our count. And from here, adding to our count is no longer running this effect. And that's because we have an empty array which is not looking for any changes between one render and the next. Now, if I wanted to run this effect every time count changed, I would have to make sure that my effect knew that count was one of the dependencies that signaled to the effect to run again. So now I hit refresh, it will run once, which is why we get effect ran in the console. And now every time I hit add, I'm also running my effect again. Under the hood, this is what's happening. When I hit refresh, state starts out as 0, and the component will take count and replace it with a 0 everywhere it can find it. So here we have an array with the number 0 in the first index, or the 0 index. Then when I click add, React will update the count from 0 to 1, and it's happening. When I hit refresh, state starts out as 0, and the component will take count and replace it with a 0 everywhere it can find it. So here we have an array with the number 0 in the first index, or the 0 index. Then when I click add, React will update the count from 0 to 1, and it will rerun my function, or in other words, re-render my app component, where everywhere I'm using count is now 1. Remember, this used to say count. Well, the second time around, it changed from 0 to 1, so now it's running this component with an array where 1 is the first index, or the 0 index in that array. Then it's going to look at the last time it saw this dependencies array, and it's going to compare an array with the number 0 to an array with the number 1. Now, I probably shouldn't use triple equals because that's not exactly what's happening here. Let me say compared to. It's going to compare this array to this array. And if any item in this array is different, then it knows to rerun this function. Now, here's the question. What if I were to hardcode an array with the number 0 in here? Let me hit refresh. We can see that our effect did run, but now what will happen when I cause a re-render to trigger? If you need to, you can pause and think through that for just a second.
It will not.
Well, I can click add, and we'll see that my effect is not running again. Why do you think that is?
Because it's same.
Well, with a hard-coded 0 in here, every time the app re-renders and useEffect looks at my second parameter of this array, it's comparing the array with the 0 as the first item in it to an array with the 0 as the first item in it. It's going to see that those are exactly the same values, and therefore it will not run this function. And that's why it's called a dependencies array. UseEffect depends on these values to know whether or not it should rerun our effect. So again, when I put count, I refresh the page, count starts at 0, I hit add, count is 1, it notices that that has changed, and therefore it reruns our effect. I feel like I've repeated myself a lot here, but I'm hoping that the concept will sink in the more times you hear it. Okay, it's high time that you get your hands on the keyboard, so let me type out a quick challenge. Okay, it's your turn to write the useEffect. The useEffect should run anytime the count value in state changes, and for now, it's just going to console log something like effect function ran. Pause now and work on this challenge. We can start our effect by using react.useEffect. As a side note, just like we could destructure useState from the import statement up here, we can also destructure useEffect if we wanted to, and just say useEffect. In fact, I would suppose this might be the more common way that you'll see it, but just like with useState, I'm going to use react.useEffect just so that it's very clear where useEffect is coming from. UseEffect takes a function as its first parameter before we had a function declaration like this. However, I am going to use an arrow function because that is how you will most commonly see it. This is just going to consters, thing that we had when we had specially on the function will only run once the very first time your component is rendered. We get effect function ran. In the next lesson, let's